So now our final problem for the STAT is from the exercise from section 4.5, and it's number 30, and we have to calculate the integral of x cubed, and then we have the square root of x squared plus 1. Alright, so the only technique that we have learned so far is the technique of u substitution. And we know that when we use u substitution, u is usually the inside of something, and we also need to be sure that the derivative of u is inside of our integral. Okay, so in this case, if we were to set u equal to, let's say, x cubed, then du dx is going to be 3x squared, and that's not going to help us at all because that derivative of u is not inside of our integral. But let's now try the way where u is usually the inside of something. So the inside of something in this case is going to be x squared plus 1. Let's see what happens. So then du dx equals 2x, right? And is 2x, so remember, disregard constants when you're looking for whether the derivative of u is inside of your integral. So do we have an x inside of our integral? Yes, we have. Well, we actually have x squared times x, but as long as we have the derivative in there, we are fine. So this can actually work. So let me just write this as du equals 2x dx, which means that we have dx equals du over 2x. So let's substitute this back into our integral. So what we have now is we have the integral of, I'm going to keep this x cubed just for now, then I have the square root of u, and then I have du over 2x. That x cancels with one of those. So now I'm left with the integral of x squared times the square root of u du. But I have a problem because I'm integrating with respect to u, but I have an x in there. So I want to get rid of that x. So what I'm going to do is I'm going to just use what I said u equal to again, and I'm just going to write my x in terms of u from that. So x squared is going to be equal to u minus 1. So this is going to be equal to the integral of u minus 1 u to a half du. So why is this a lot better than the one we started with originally? Well, the one we started with originally, we had x cubed times the square root of the sum of something. So we could not multiply that x squared into our square root. But now we have a square root of a single term, and we can multiply that into our brackets, and then we can easily integrate. So this is simply going to be the integral of u to the 3 over 2 minus u to a half du, which is going to be the integral of, I'm going to integrate now. So it's u to the 1 power higher divided by the higher power. The same for this one. Alright, so that is just going to be 2 over 5 u to the 5 over 2 minus 2 over 3 u to the 3 over 2. Right, and what am I forgetting? Well, I am forgetting my constant. Don't forget your constants if we have an indefinite integral, so it's plus c everywhere. Am I done when I get here? No, I'm not done. Why am I not done? Well, originally I started with an integral in terms of x, so my answer has to be in terms of x, so I have to replace u by x squared plus 1. So it's going to be 2 over 5 x squared plus 1 to the 5 over 2 minus 2 over 3, that's very bad 3, x squared plus 1 to the 3 over 2 plus c. Right. Sorry guys, I just realized that I left out this 2 from this step. So I'm supposed to have a 1 over 2, a 1 over 2 here. 1 over 2, I have to add it in all of my steps again. And then I can multiply it in, so this is going to become 1 over 5 and 1 over 3. Right, so it's correct now.